Hello, Kennedy. Hello, Spencer. Hello, Connor. And hello, Chairman and Zane. Thank you for your patience to stay in class for basically the whole semester. It's quite an achievement that should be rewarded. So we are done with academic program with like didactic courses, and now there are remaining efforts for the project. Today I will declare requirements for the written report, which is due in whatever 36 hours, 37 midnight of Thursday, and then on Friday we will practice peer review. So I'll tell what it goes. And tonight I will be in the lab to help to tie the loose ends if needed. If some of you didn't started the project yet, it is not yet late. It is possible to do everything in 2 hours during the lab. And if you already have done something, then there is a chance to perfectionize. There is a little thing that I didn't include in any lectures, and I will either announce it on the lab, or if I will be quicker than my own plans today, I'll tell it later. It is so-called Arrhenius law that you may know about. And yes?
We learned about it in Gen Chem.
Okay, good. And then you know how to extract activation energy if you have data for temperature and rates. If you don't, I can remind it either at the end of today's this class or at the during the lab. The primary client for Arrhenius law is Jared. What you are doing is mostly fitting it, but rest of you may use it as well. So requirements for the weekly reports.
Yes, sir. Got it.
So
Question.
yes, please.
When is our final date?
Did you check what? Did you check?
Wednesday?
At 8 a.m. I think.
It's great fun. Do you want to do it at 8 p.m. or 8 a.m.?
A.m.
I think we'll do vote by email if you prefer some other time.
Perfect.
For a bet, I can come at 8, but I think it is not the thing that is not the maybe would be most reasonable if we do as usual at 11.
Might be Thursday. Let me double check.
But let's check, and I'll send it for vote by email. Maybe do the poll to make sure that it doesn't conflict with your other exams. But definitely, it would be better to do during the according to the online. Spencer tells
Thursday
8 a.m.
Thursday at 8 a.m. Perfect.
Oh.
That's even better.
Okay, and we can do Thursday, but a little later if everyone would approve, like 10, 11, something, to reserve time for morning coffee. Yeah, thank you much, Spencer. Okay, and as you probably recognize from the image, it is not the physical chemistry, and I'm not the author of this statement. It's my humble borrowing from Wikipedia, and the words about print 3 copies, or you will see print 4 copies, is kind of obsolete. I think it should be replied by email as a Word document. And something goes similar to previous years, but of course we are 2 years late. Do not tell I'm not going to do anything because the dates are wrong. So we in this class are not first people on the globe who do written reports and speak publicly. And way before modern science was developed, it was already part of the human activity. So in some sort, we originate from Western civilization, and Western civilization in some sense originates from Greece and Roman Empire. So we may look what they were doing for making their written reports and public talks. Because the way how the information is communicated between people doesn't change much. The content changes, but the ways how to organize and communicate are the same. And this set of suggestions would sound much better after all results are complete, which may or may not be true for your cases, but the schedule gives us time on today. So the Aristotle was making some notes about how people communicate with each other and philosophically considered that one goes through design, invention of basically what to speak, the style, how to arrange arguments, and I will go to this a little later. The communications, including scientific communications, have competitive nature, very similar to a lawsuit when like attorneys and then prosecutors argue in presence of a judge. So there is a need to convince someone, typically reviewers, that what you did is correct. If you can provide mathematical proof, it is good, but it is not always possible. And the little tricks of arranging information in a logical way sometimes can complement mathematical rigor. Which doesn't mean that I'm against the rigor, but one shouldn't shut it in the foot and make the case worse. So, and then the way how the arguments are, objective data and arguments are presented and communicated to the one whom you want to convince is another part of scientific communications. Then there are some things about like making it vocal tone and how to memorize him or herself, but it is a little obsolete because scientific data are more dry and it will be strange to sing instead of tell, or to print scientific paper on the pink paper with some pleasant smell. So the invention is what you already did or what you're in process of doing. Last two things are skipped, and the arrangement of the elements of your results, both like figures, tables, and words, is something that we're going to focus on. And Greeks and Aristotle as their representative for more general and philosophical, and Romans were more focused on getting to the point. So the goal of any public speech, and I cannot serve as an example, it is ideal speech, can be decomposed on three basis factors. To, if any of you speak Latin? No? Did you? once in 3 years, one of the class attendees knows how to pronounce it. Directere, decere, movere. So to please audience to communicate some new information and to move, like induce some action. Like if it is a lawsuit, to make the decision in favor of your client or of yourself. In case of scientific papers, to accept your paper. In case of a class, to give the higher grade, or just to believe that what you did is correct and legitimate. So, but by human nature, this part needs to be verified. So here, maybe the most interesting and best slide from today's entertainment. So Cicero was the speaker, politician, philosopher in Rome at the time of Caesar, or a little bit before Caesar. He was basically in his in opposition to Caesar, but he made several written works, and one can read them in translation or in the original, which give basic rules how to make your public speech to achieve the goal in the best way. So it is not the formal requirements to what you speak or to what you write, but it is kind of a shortcut how to arrange your information in the best possible way. And there are, according to Cicero rules, there are 6 parts. So exordium, introduction, when one tells why the problem you're doing is interesting, or just gives some exciting fact, or just attracts attention so that the audience during your speech doesn't fall asleep, or the reader, whoever reads your writing, doesn't think, boring, I better read more news on Google. So it should be some to attract attention, at least for the next sentences. Then next one, narration, which sounds like English narration. It's review. Like if the problem is interesting, is there anything done to solve it in the past? Telling the today's situation for the problem you're looking at, you're working at, you're going to present results about. So the next one, divisio, which sounds like split, divide, division. Yes, in some sense, like a table of contents. So to give readers and listeners a little outline what to expect. And it all is based on the human nature. So if the reader or audience wants to listen, wants to get to the final point, I want to listen to you, but I know that my ability to concentrate is limited. And I decide, okay, I will concentrate for 20 minutes and then relax. And if I do not know an outline, I can go to relaxed mode earlier than you get to the point. So it's kind of a reminder, wait, this, and this, and then you'll get the most interesting part. Confirmatio, proof of the case. So in the previous parts, or at the end, it's a matter of taste, there is a main take-home message that you want everyone to believe, you want everyone to act accordingly. And for your main message, there are some arguments, like mathematical proof, or computed data, or measurements from observation, or evidences if you are in the court. So they are the section number 4. So proof of the case. then next one, confutatio, is arguing with potential opposition. It is also natural way for human thinking. If I hear something new that contradicts to my expectation, I want to say it's all lie, it's all wrong. You did a mistake. I do not believe it, or something is suspicious. So against such potential suspicion, the speaker should be ready to it and think ahead which arguments can be organized against him and prepare counter arguments. I think we're not yet done. Yes.
No, you're fine.
Okay. And the peroratio, the conclusion is summarizing the arguments. I like, and the last two probably do not work for scientific communication. It was more reasonable for ancient Rome, when whoever disagrees with the speaker should be cast in the negative light, and everyone should love the author in the case. Right? So how do we transform these ancient rules into today's? So first one is like abstract of the paper. The statement of the case is introduction, which you just describe why you think it is interesting, what you know about this problem. And of course, we are all limited in space and time. Sometimes it could be one sentence or one paragraph. If it is a true big live scientific paper, then I should remove this from the eyes of sight. Typically, the eyes are closed if the pictures are of the people who's doing something wrong. So people do references to like 20 or 100 scientific papers here. Of course, we cannot do it in our limit, but if you have in mind some paper or two, you can say here. Method, outline of the major points. It's not equally, outline of the major points was a little bit different, but in scientific community, one typically lists the methods and gives, in our case, gives major equations or explains the algorithm. Again, understanding that we all are limited in time you can work on it and space you can fill, but something to induce trustability in the reader. And main equations like Hamiltonian evolution operator, like parameters of your simulation are very appropriate for this section. Results is like proof of the case, confirmation. When you just list whatever your objective results are, showing figures, tables that confirm your main finding. Then it would be in scientific community, often results and discussion are combined, but they're different things. In results, you just communicate the facts, and in discussion, you tell, like, you can play a role of attorney and prosecutor of your own case yourself and try to think what audience may think is wrong in my case. Then you come to this idea and then you try to argue with it. And then you put it in the discussion. Then it looks very solid. If you accept that some of the audience may have doubts, but you know why these doubts shouldn't be a problem. So if you could put a sentence on this, it would be really, really great. And then conclusions, you already know. If you disagree with me, then Cicero will cast you in the wrong, in the black light. So how do we, if you believe this translation of Cicero rules into modern scientific writing, how do we fill these sections? And sometimes people combine and simplify things. So why you all were doing problem of your own choice? So you have some motivation to select one or another problem that could be unknown for me, but if you inspect your own thoughts, you probably can answer these questions. Why it is interesting for you? If there are references, fine. Identify open problem, like which question you are trying to answer with your mini research. And I will return to this again and again, even if your goal is just humbly complete requirements of the course and get everything in or whatever your goals. In this papers, one needs to respect the style of human thinking. And in order to prepare reader to go through, just you already know what your main answer, your main finding is. And even if you started without like free browsing, but you found something interesting, you can pretend that you were intentionally planning to answer this question, like a widow detective story. And it just helps reader to go through. So what's the main question? And there is a really good style of writing that helps reader to get through. You can, again, you pretend once for the question, and then second, you pretend that hypothetical answer. So you didn't present any methods, any results. And here's an open question, and based on the common sense, probably the answer will be the following. For example, for the problems Jartus is doing, the hypothesis is that the activation energy, the temperature needed to overcome the barrier should be the same as the height of the barrier or all over. Right? It's quite, it's not novel. And you can say, here's a hypothetical answer. If, maybe it will be, activation will be lower than the height of the barrier. But I do not know whether it's right or wrong. Let's do some calculations to prove it right away. And then you just express hope that methods from the course can help to prove this hypothetical answer. So, and I think it's possible to fit into a couple of sentences so that you do not waste much of time. Now, methods. Based on what some attendees of the class were doing in previous years, please do not do quotes of the code. I know that you know how the code works, you do have it, but if you quote 300 lines of the code or even 10 lines of the code, it's not what people do in scientific papers. Typically, equations are designed to summarize ideas, and they are better presented. So try to use equations here that we think are relevant to your new research. Results and discussions, just place their figures that you fabricate during your research, number them, and then go from figure by figure explaining. Yes?
I have 20 figures. Should I choose like the most important ones, or would you rather me put all 20 of them?
Absolutely perfect question. With 20 figures, you
20 times. I have 100 figures.
Okay, so you already do multi-panel, several panels in one figure.
Okay.
Right?
Yep.
So it's one case. If you to compare apples to apples, if you have few similar figures, you can well, right now there is no time to do many adjustments, but people do several lines per one figure, or put several panels like A, B, C, in one.
So compare the most showing results.
Right,
Okay.
right. Because if you have more than 7 figures, it will be unreadable. Just think of yourself, what would be possible for you to read if your classmate writes similar thing. So I appreciate your effort and productivity, and you can brag like through this research, 100 figures were generated, but here are the most showcasing ones. Okay. And in the conclusions, so you can feed discussion into results and tell why results look this way, why you believe they are correct, if you have time and energy, because I understand that it will all will be done in limited time. And in conclusions, you come to surprise. Our hypothetical answer was correct. And we know that it is a little bit made up, but it is not your true, even if it is not true way how the research was done, it is really efficient way to communicate the story. Like, I'm learning myself and trying to do it, to practice this thing, and you may have seen it through the lectures when final result is introduced first, and then there are steps to prove it. So I hope it is a better way than to do some boring stuff and at the end of, oh, what a surprise. Some people may have no patience to wait until the end. So tell that the results support hypothetical answer, and then just share your arguments or just that you're confident that the results are correct, trustable, justified. And then if you had any references, you can put them. If no, it's fine. Typical scientific papers that come through competitive peer review have typically more than 20, and it can go up to like 300, but like 60 is normal in chemistry, and like 30 is normal in physics. Okay, so first part, if you have doubts how to justify in the very beginning of introduction why your research is important, you can make up some arguments. Maybe you already have your personal vision, but possible motivations are just satisfy curiosity, find that this problem is most doable based on what you remember from the methods. But some people live in the very non-selfish world with believing that research may make the world better. True or not, but it sounds always good. And you may try to connect the problem you are doing to any of the big world problem. Like if dice is dice solar cell, it gives energy for free to everyone. Rocket fuel will bring us to explore extraterrestrial life or make colonies to different planets. Right? And one can give such simple arguments all the time. Generally, there is a through scientific effort, one can always find how it positively affects life of citizens through like in scientific activity. One either makes teachers for schools that gives general education. And this year, no one selects war model, but it would be this way, just giving education. And other path is to create knowledge in form of application patents that come into industry and then gives free energy, cell phones, new drugs, security, and then it goes to satisfy needs of regular citizens. And one can feed basically any idea that you're working on into this schematic diagram. So it's not my personal wish. It is just standard situation in the scientific community that whatever you do will be judged in a critical way. And this, in case some of you consider entering research activity, it can be later used for you in your big life, so to say. So authors like you want or have some motivation to complete a project and report it because it is mandated by the system in order to show productivity, to get funds to support your research. And salaries one needs to make publications, development reports. There is other role in the community, reviewers, which are chosen as peers from the same people, but they are invited by editors of journals and instructed to evaluate this and that work, and they're instructed to be critical. But please find any weaknesses and give us an argument why you should reject this paper. So it is just how the system is working. And in face-to-face, sometimes it is arguing. In blind reviews, it's just exchanging the arguments in writing, and one should be ready for it. So this little part of, or maybe not little part of the scientific activity and communications that you started earlier, we should be ready for it. So, question about results and figures. So, like, this is very tentative and approximate. And if you have less than 7, I'm very fine. I'm just showing a possible arrangement. So figure 1, schematic explanation for the problem. It can be just scanned, hand drawn, or like a couple of boxes from PowerPoint. If you're doing something that can be expressed as Hamiltonian potential, you can show potential, or you can combine first and second, just to help really to understand what you're doing. If eigenstates for this potential are available, I promise to send you one. One can add it, but if not, you can skip it. Sometimes looking at eigenstates, one can get better idea of the problem. Examples of typical dynamics. So we were getting these stripes, orange on the green background or whatever, when snapshots of the dynamics of the wave packet are summarized in 3-dimensional figure. Right? So it's you cannot show it for all runs that you need, but for most casing, it's very appropriate, and they are visually appealing. One can easily explain what it is, and it's a good argument for the final result. Population of the product state. I think this one is applicable to all of us. So in Jared's case, it is just left and right from the maximum of a barrier. Barrier space will be like reaction and product, and then reactant and product. Population in the reactant decreases from 1 towards 0, in the product grows from 0 to 1. If it is Horner and Kennedy, then it is also amount of electron probability to the left and right of the part of the cell. For Horner, it is probability for electron to be on the die and probability of electron to be on the semiconductor. So this population is quite expected. Then the number 6 is rate of transmission as function of your control variable. So the population grows with different pace. And the pace how population grows depends on initial momentum, P naught, which is with some square root of temperature, right? The higher the temperature, the quicker transition. But in some projects, control parameter is not temperature, but something different. So for Zane, it is energy offset. Right? You find how the rate depends on energy offset. For Kennedy, it is voltage or electric field. So the slope of your addition to potential. And this dependence of transition rate as function of this parameter is core main result of the project. So this little thing that in this form of simple dependence, like you put different values of P naught on the x, or maybe P naught squared divided by 2 masses on the x, and rates on the y. It's good. It's really a great thing. But sometimes the rates are changing by orders of magnitude, like 10, 100, 1,000, 10,000 times. And then this linear dependence may not show all details. So there is a best way to reduce this dependence, and this is primarily for Jared, but others can do similar things. So instead of momentum squared, instead of temperature, one uses x-axis as 1 over time. And on y-axis, instead of rate, one uses logarithm of a rate. So this is a typical way to analyze Arrhenius law implementation for real data. And instead of complicated dependencies in this hypothetical figure 6, which changes by order of magnitude, in this logarithmic y and 1 over t or x, it will look very simple. So most chemical reactions will look like a straight line, or points through which you can put a straight line. For Zane, of course, you put energy, but the rate should be logarithmic, and then it is expected. Then it will be like parabola with whiskers down, like minus x squared. And similar things can be found in other projects. Okay, so figures, and if you haven't completed or haven't started the project, main goal for tonight is to collect all figures, and main goal for tomorrow is just to explain them according to these lines.
For the presentations,
yes,
are we just going to show our data, explain the overall thing we're doing, or do we want to more or less go through our entire paper in a slideshow?
How much you can fit into 5 minutes?
Not much.
If you can fit all your paper in 5 minutes, it would be really great. And I cannot view the predict future, but I can tell about the past. In the previous years, I was inviting guest visitors to the final presentation. Like typically, I was looking who our scientific advisor, and was asking the advisor to come to see epic glory.
Failure?
Glory. But sometimes it's not possible of the schedule, and some practicing scientists. And after 5 minutes presentation, there is a time allocated for questions by class attendees and by guests. So answering the questions, really answering them confidently, makes the best possible impression. And by giving a good introduction, maybe even skipping some results, prevents audience from asking silly questions. So if you explain what you are doing, and you show method, although you already presented methods on the previous presentation, if you just briefly show it, it disarms a lot of questions.
Okay.
From previous years, I was a bit surprised, and I was given how to say, heads up and disclaimers to visitors that attendees of the class have excellently presented methodology. Now we are looking only on the results. But in spite of such declaration, it was again and again questions like, what is evolution operator? How you change time step, like more to the previous presentation. By some reason, it was question of interest to a lot of visitors. Just sharing the impression. Okay, 5 minutes left. So, and here, this message is going to those of us who didn't start the project. I hope it is not no one belongs to this category today, but just in case. So, what to scan, which parameter to change. So each of you have control parameter. Temperature through momentum, for most cases, energy or potential. So we change parameter, we run the code, record value of main observable, which is typically the rate, and repeat. And then float observable as function parameter. Basically, what on previous slide was figure 6. And control parameters differ from project to project. Last year there were exotic projects on Spin Echo, therefore I needed to speak more about it. But this year no one selected it, so it's a little simple. Yeah, I think here it is yours.
Do we only have 5 people left in the class?
1, 2, 3, 4. Yes, and 1, 2, 3, 4, 5. Maybe 6. The August, I know that his presentations were strong. He's really well prepared and was doing great, but he may have some medical reasons to skip or postpone.
Okay.
But I wouldn't be surprised that the doors are open to him and he's a registered part of the class.
Okay.
This, thank you for the question. This gives all speakers a little lag to speak maybe 6 minutes rather than 5. And even if, well, I would be really enjoying listening for longer. But we should respect personal time of everyone in the class and anyone who will visit. So if I say like 6 minutes or 7 minutes, then it will go to 15. Yes?
For our final times, isn't that a 2-hour period? Or are we going to try to stick with the 50 minutes?
The questions will eat time like crazy.
Okay.
And I'm trying to declare and ask class attendees to stay within 5 minutes, and even to design some ways for either extra credit for being within 5 minutes or deducing credits for being longer, but it doesn't work. Each year, someone is speaking for 20 or 25. So
Stick to 5 minutes.
Try to.
Okay.
I know it is very hard. If you haven't done anything, you think, oh, okay, I do not want to present. Maybe it will take me 3 minutes. But believe me, everyone. When we were talking about methods, some of you were champions in being brief. When it goes to results that you generate yourself, it is very natural intention to speak for hours.
Okay.
What I can share my personal tricks. It's not from undergraduate school, but from graduate times. I was preparing backup slides for answers on the questions that audience may ask.
Okay.
And then it also makes a very good impression when someone asks something, trying to like either learn something new or maybe even show my ignorance. And I was expecting your question. Here are the questions.
Yeah.
Yeah, I think it is just examples what to change in different things in the last years. Here is what we already saw, like full chart of the research process. And here are the this flow chart in writing. Basically, we discussed everything, but if you have some doubts, you can just look through. It may be too excessive, too much, but if you look through it, if you have some doubts, it will give some prompts. Differential rate table. And then by slope of the logarithm of rate versus inverted temperature, one gets activation energy. It's just by taking logarithm of Arrhenius law when it's getting this formula. And I plan to cover during the and we do not have time for criteria, but on the Friday meeting, I will offer like set of questions that each of you will serve as both as authors and reviewers, and you will give through some questionnaire about the work of your like peer, and answering like several questions and giving like publish or reject or slightly improve. Okay, thank you for your patience and attention. Looking forward to see you 5 p.m.